this event came about because I was in touch with us at Govis, saying that Francesco was in the country and suggesting that we might like to help organise a Wellington event to sort of be a counterpart to the Auckland event that you've already done up there. And so we're happy to be part of all of this, and thanks very much for approaching us, OSS, and for the catering as well. I might hand to you to say a few words in just a minute, and I'll just do the housekeeping first. Yeah. So we've got a number of people online. Hopefully everyone online can hear us. Any thumbs up or waves, just confirming that you can actually hear what we're saying. One can never assume these things. Okay, thank you. If you can't hear anything, just please leave a message in the chat or let us know. When we come to the Q&A, you're also welcome to unmute yourselves and ask your questions that way. Our preferred way for managing the Q&A is using an app called Slido. There's information about this on the screen. There's a QR code you can scan with your phone. Go to the slido.com site and enter in the event code. We prefer to use this for Q&A instead of the Teams chat because it means that everyone online or in the room is on the same platform for Q&A. We're not jumping around. And you're also able to upvote questions and so on there as well. So if you've got a minute now while I'm talking, make sure you scan that QR code and get on there with your phone. Otherwise, you'll get a chance later as well. For those of you in the room, you're welcome to help yourself to food sort of before or while the event's underway. Just sneak over there and try not to clink too much. If you need to use the bathroom, you sort of head out the door here, turn left, and then turn right into the main sort of foyer at MB, and then the toilets are on the right across from the cafe. Shouldn't need any swipe card access to get there and get back. And in the event of an emergency, listen to Jacob and Chris, who are from MB, and can tell us what to do, where to evacuate to, and so on. And that's about it. I've already said that the event's being recorded, so you know about that. And Chris, would you like to say anything from OSS?
Yeah, thank you, Chris. Just quickly, I'm thrust in the limelight by my colleague Simon, who was normally going to front. This was on a plane coming down this morning from Auckland, and the plane turned around for a medical emergency. So you've got second prize, which is me. Just to quickly say, look, OSS is proud to be associated with Govis. We love what Govis stands for and what it does, and we're also delighted to bring the Strato team here today to hear all the good stuff that they're doing. So thank you.
Great, well thanks. Just quickly before I pass to you, Francesco, to start presenting, I thought we should just see if anyone wants to, we should get a sense of who's come along today. So in Slido, for those of you who are there, I've got a poll open at the moment, which is what sort of data work do you do? There's a chance to describe in one word, if you're willing and able to just, what do you do? Are you a data warehouse developer? Are you an architect, data scientist? Do you do a lot of data modeling? Let's see, we've got one person typing already. I'll put one in for myself.
Business advantages. Doesn't cost.
All right. Oh, it's a bit slow. We'll leave that up, and you can keep filling that out. There's a few more coming in. Let's get the screen here. Lots of analysts. These are work with data products. I know a lot of my former colleagues at MB. Hopefully, some of you have made it into the session. We've got plenty of, well, MB does have plenty of data engineers and data warehousing people. Great, well, thanks very much. It's good to, hopefully that's useful for you, Francesco, and I'll stop sharing my screen and I'll hand over to you.
Thank you, thank you. Hi, everyone. So before I share my screen and start pressing buttons a bit weird, I wanted to give a bit of context while we are here. So Today we are talking about data as we always talk about data lately. Data is the new thing, AI is the new thing, and data is based on AI is based on data. So of course data is very important. And the chat of today is called Modeling Your Data to be AI Ready. Are we AI ready? I'm not sure. Maybe yes, maybe no. Maybe we are, but we can do better. So in the chat of today, we are discussing a bit how to be AI ready, and especially we say, okay, we are here now, but we will do a step backwards to what actually most people are doing today as data analysts. I saw Power BI on the slide, and many people are doing the classic data analytics, which is still the main thing that we are doing today with data. So in theory, AI is doing the same thing, but in a more automated way. So the question is AI going to be able to do the job of data analyst and go even beyond that? Or can we do something better? Meaning, if imagine that AI is a bit like our new employee in the company that is super experienced, has a lot of years of experience, but they just joined 2 days ago. So AI cannot know everything about the processes of our company, the data of our company. So we need to help anyone who is doing analytics, no matter if it's a human or a robot. We need to help them to understand the context and make sure that we are giving the right information to make sure that analytics and analysis of data is possible. So I'm sharing my screen now, and I will make a presentation, and it will be a bit of a mix of a presentation and live demo, because I'm really hands-on. I really like to have my hands on data, and also today we are going to do something like that. So we are in Wellington, which is my first time. So probably I will climb this hill tomorrow morning. I don't know what's the plan. We'll see. Depends also on the weather. We had a speech last week in Auckland, and it was fun. I had a lot of participation, a lot of questions, curiosity. So I hope it will be the same. What I'm sharing today is a different way of doing things, even a different way of thinking, the way how we interact with the data. Okay, how to be ready with AI. First of all, about myself, I am an electronic engineer from Bologna, Italy. I have always worked in business intelligence. I started with business objects, which was for me like the perfect, it was the perfect tool of a semantic layer, the perfect environment that pre-joins all our tables, so we are done, we are good. Except that it was not done and good, because there was a structure called universe. And I was working in companies where they had 17 universes. And I said, well, the name universe should be because it's all there. It's one universe. That's what it is. There were 17 parallel universes. And the business user had to choose in which universe to find their data. And the universe names, guess how they were? Universe 7, universe 14. So that's very bad metadata, and especially the very, very deep problem that I want to analyze. Why did they have 17 universes instead of just one? What was so difficult in putting everything in one universe? So that was like opening a world to me. Also, I didn't love electronics very much, and then I started working, and they told me, you will work on business object. I said, yeah, I love it, because it makes sense to me. Then I worked a lot on Click, and one thing you should know about Click, it pulls all the data in memory. So this solution, which I invented, called the Unified Star Schema, comes from, actually from Click. There was something similar called the link table in Click. And Click by nature pulls all the data in memory, so you can build this big table that joins with everything. And that's the background of my invention. Then I call it my invention because I expanded very much what was in Click initially. And that is a bit the background that I had, and that's why this is ideal when your data is big but not huge. That's where the Unified Star Schema shines. And then Tableau, Power BI, ThoughtSpot, I've worked on all these tools and many more. Then I worked on data warehouse. Again, that's relevant because as a data analyst, you read from a data warehouse. And I said to myself, I want to understand why the data warehouse is such a mess. So I joined Teradata as a company. I was an employee of the company. And after a few weeks, I already knew why it was a mess. So now I know why the data is prepared in a way that is weird. I know exactly the commercial reason why in Teradata you find data that is much more complicated than it should be. Then I work a lot on Snowflake now, and I am a consultant at Cube.dev. I collaborate with Strato, and I teach at the University of Bologna. I do workshops and education. So I'm a freelance, but I like education a lot. I like a lot to share, and also to share like in two directions. So share my thoughts, but also collect the thoughts of other people. And my mission is to make data analytics easier for business users. That's my job. So can business users produce this on their own with artificial intelligence? So we open our ChatGPT or whatever, and we say, I want to see a chart that shows the trends of the sales of last year. Can we get this done out of the box? Of course. So why am I speaking? We are done. We are done for today. We close the meeting. We can start our breakfast. No, it's not like that. It's there are steps to follow which are really not obvious. So I brought here today a use case, an example of something very simple that you may want to do with your data. I brought a database that is actually, many of you will know it, it's called AdventureWorks from Microsoft. But I made my own version with tables that instead of having thousands of rows, they have just 4 or 5 rows. Because already with 4 or 5 rows, you already see the problems in front of your eyes. So it's much easier to understand where the pitfalls are. Okay, so I made an example of 3 reports that you may want to do with your data any day. Internet sales amount by product category. What can possibly go wrong with that? Reseller sales amount. So internet sales, reseller sales, 2 different channels of sales by product category and promotion category. And then the third one, internet sales amount and retailer sales amount by product category and promotion category. So the combination of the first 2, basically. So you would say, it's easy. Basically, you look at the third directly and you put everything there, and then you've done everything. Yes, but it's not so obvious. So with the existing BI tools, is it an easy task? Let's try it with Tableau Public. So because a lot of data analysts are here, and we all are ready here in this room to speak, or people at home to write in the chat, I open my Tableau Public, and I open my data source, and I try to see if that task is easy. So the first one is internet sales amount by product category. Let's do it. So I read from the original version, original meaning the simplified by me. And then there will be another file transformed into USS, which is Unified Star Schema, which is my thing. Let's do the original first. So Tableau sees a list of tables here. Because our request is internet sales amount by product category, well, we have a thing called internet sales, I guess should be fine. And then I want product category. Oh, I'm lucky. There is a thing called product category. So, why are you laughing? So I double click. Well, what happened? Why I have a message? It's difficult to read. I'm new a bit in data analytics. I haven't seen a data model yet of this data set. A data model with multiple base tables creates a data source where some fields are indirectly related. Okay, I don't get it. Can someone please help me? How do I do internet sales by product category? Can you please guide me? Who is familiar with Tableau here, by the way? That's the new trick, no one. So that's the new trick of Tableau. When you double click, it does a special thing. Before, Tableau was just beginning to create a relationship. So this, now Tableau wants to know how to join these 2 tables. And okay, let's see, product category, there is product category ID and name. So I guess the key is this. So here, let's search product category ID. It's not there. So I'm a bit stuck, guys. I need your help. I'm lost. So probably we need a data model. We need a map that tells us a bit how the tables are organized. So we can open the data model, and life will be easy. Easy, but not so easy because it's unreadable. The problem of data models today is that they give you all the list of columns, the full list of columns, but then they are unreadable. So they are not very helpful. So a first thing that I recommend is to make a decent data model. So this is the data model done with my technique. Just all the arrows go from left to right, and you only see the names of the keys. So all the other things, okay, the page is what it is. You cannot put a 1,000 column names, right? But this way, we see that internet sales is here. Do I see? Yeah, probably everyone sees my screen. Yeah, I guess you do. The mouse moving, yeah. And this is the product category. So as you see, I am a user who should make this connection, and I am not a data analyst as a job. I am a business user, and I want this to be done. So for a business user, it's already a bit difficult to know that if you want to see the internet sales by product category, you need to build this chain. And that's what AI is also supposed to do. So AI is supposed to watch this data model and understand that to produce such an easy report like internet sales by product category, well, you need to build 3 joins. Otherwise, you don't manage it. No problem. We are all smart. So we put this away, and we start by putting, what was that? I already forgot. No problem. It's here. Product, then subcategory, then category. Okay, we can do it in seconds. We double click on product. Forget about that. We do that. And then once it is here, we go here and we say, yeah, the key is product ID. So I have, that's the product ID. The data model should help me also with the names of the keys. Great. And as you see, I had to select the fields. Now I click on product subcategory, double click, but this time it's magically connecting. Do we have an idea why it's magically connecting?
Names the same.
Names are the same, exactly, thank you. So when names are identical, well, there are 2 conditions when most BI tools are making the join perfectly automatically. Names must be identical, and it must be the only pair of names identical. So if you have 2 tables of 100 columns, but only 2 columns are identical names, and all the others have different names, then it is connecting automatically. Most BI tools work like that. Python works like that. R works like that. So that makes sense. And then I finally put the product category, and I produce, finally, that's my data model. Now that I've done the data model, I go to my sheet and I produce the report. So in the slides, I am doing all the things I've done now, except that also when you are doing things this way and you're not an experienced user or you are AI, well, you fall into these pitfalls as well. There will be a moment when we'll say to AI, hey, I'm not good at Tableau, please do it for me. But Tableau, AI cannot use Tableau. So you have this error message because things are not joined. Then they are prepared to be joined, but they are not joined because we don't have enough, we don't have the correct data model. Then I go to watch the data model, I watch a better one. And then finally I produce this data model and I produce the report. Perfect, we have our report. Was a bit tiring, eh? But we did it. AI did it. We finally achieved the first report. Cool. What do we do as soon as we have a report? We usually are unhappy because we wanted something else. So we go for the second report. So what is the second report? Let's see. It's reseller sales amount, not the internet, but the reseller sales amount. You know, when you're an analyst, your users, they always change idea, right? And they say, oh, sorry, I didn't mean that. But I understand that. I am also a client of other people, and I say, sorry, my bad, I didn't mean that. We have to be patient. It's our job to help them to see their data. So they say, I don't want to say to see internet sales amount. I want to see the reseller sales amount by product category and actually also by promotion category. Okay, no problem. What can be hard with this? Reseller sales amount. Where can it be? I go here. Reseller sales is here, so it's another table. So I should do the same trick, join it with product, which joins subcategory, which joins category, and I will also need the promotion. Let's do it. What can possibly go wrong? So now I take internet sales, and now I take reseller sales. I double click. So this time it's actually a new base table. So it's what we analysts would call another fact table. So instead of joining it like that, we just put it as a self-standing table. Go away. Go, leave me alone. Okay, so we put it here, new base table, new base table. Okay, so now that we have a new base table, we join it to product like that. Again, we have to specify product ID and reseller sales product. That's what it is. So that's quite okay. It's two fact tables sharing the same conform dimensions, the basis of Kimball. Fine. But I also need what was that? I don't remember. I got to see the promotion category. Where do I find the promotion category? Well, I hope it will be in this table called promotion. So I join this table called promotion. I double click. Okay, it's here. It puts as a base table. It's not a base table, so I need to know. And again, imagine a business user understanding the difference between the double clicking and having it the thing here self-standing, or actually it's sticking. It's called spaghetti. It's called noodle. So this sticky spaghetti that is trying to attach everywhere, and I said, leave me alone. What should I do with it? So the right thing to do, and it's not obvious, is that you need to go here, okay, close to reseller sales, because you want, that's the data model. It says reseller sales, then promotion, so you join them by the promotion. Here the key names are different, but you need to join it this way. So promotion key, and here it's called reseller sales promotion. Great. So it should be fine. So I can go to make my report. Again, we can do it on our slides. So again, I added this, So they need to be added with the correct key. Perfect. And then the correct key. And then I do the report. So I can do this report, which is now showing me the product category name, the promotion category, and the figure about the reseller sales. Good. Final step. And finally, we are going towards the direction of the thing I want to show you. So I'm taking a lot of time today to show you how it is, because then when I show you how it is with the Unified Star Schema, we are already taking a coffee because it's finished, because it will be much easier. So it's taking me a lot of time to show you how things are today, because it's a bit difficult. Not for analysts, like most people in this extended room, but it's difficult for business users, and frankly, it's difficult for AI, because AI, everyone says it knows everything. No, it doesn't know everything. But then we say, okay, we connect the AI to the metadata of my database, so there will be the constraints, so the AI will see the constraints and will know how to make the join. What is a constraint? A constraint is a concept of the 90s and 2000s. You had constraints in Oracle. In Snowflake today, you don't have constraints. You can declare the keys and the connections, but most people don't do it. So AI will not find this information in the engine. It's not there available. Most of the times it's not there. So we need to understand that we need to provide context to AI and say exactly how tables are joined. As you give to your new employee this map, this data model is a map that says how to connect things. Well, the same way as you do it with the employee in your company that joined yesterday and he or she needs some help, well, you need to do the same with AI. We need to help AI to know what to do. So that's the last report I want to do. So it's the combination of the first two, internet sales, reseller sales, and I will have a question for you in a minute, so be ready to answer. Internet sales, reseller sales by product category and promotion category. Cool. Well, we have internet sales, we have it. Reseller sales, we have it. Product category, we have it. Promotion, we have it. Is there anyone that already now suspects that we will have a problem with this structure? I'll leave you a minute to think. We have everything, like, you need to prepare spaghetti carbonara. Okay, you buy your spaghetti, your bacon, your egg, you have all the ingredients. It should be fine. What can possibly go wrong, right? Let's see someone at home. How many people we have connected?
They're not connected, no, because it should be filtered by promotion, that's right.
Okay, I heard something very good.
Anyone online?
How many people do we have connected now?
40.
49. I don't know if you heard what was said here in the room, but with your own analytic, you know what, I can put also the data model here. So this is the data model. Look at internet sales connected to product and internet sales connected to promotion. Reseller sales connected to product, reseller sales connected to promotions. Sorry, the mouse is very slow in the rendering. And so basically that's what I call the X situation, where two fact tables connect with two dimensions. So it's like everything is connected with everything, basically. As an X, you see it here, the X. So you see the two fact tables share two conform dimensions. Okay, so what were you saying?
A filter by promotions should be connected.
A filter by promotion?
Yeah.
What is a filter by promotion?
No, if you need specific data, you need to take this entity which related to other database. So you need to connect somehow.
Yeah, but for promotion is okay. So promotion is here. We have it as connected to reseller sales. Does it work?
No, maybe to because it just gives all the data, it needs to go to results, right?
Let's see what happens. So I go now to make my report. Well, actually, don't want to do it so slow, but you trust me, I did it at home. And this is the, this is the result. Now, please look at this and tell me if this report, in your opinion, is correct or not. You don't know the data, of course. It's numbers that I made up. But the most attentive of you would probably notice something.
Total is wrong.
Total is wrong, which is a nice way to phrase it, because actually the total is correct and the others are wrong. But yeah, you got the point. So you look at the reseller sales amount, 14 plus 14 is 28, plus 25, 53, looks good. But the other 700, 300, 700 doesn't make 1,000. So the total is wrong. But because I know the data, I'm telling you the total is correct, but something is very weird there. So the number 700 is repeated. Oh my God. You imagine, I have done this job from 2001. I knew, I have seen this thing first time after 3 months that I was working. And I worked for more than 40 companies, and they all fall into the same pitfall. So that report is wrong. It doesn't reflect the data that it's reading. And the biggest mistake is that most people say, okay, the report is wrong because the data is wrong. No, the data is correct. We are reading data the wrong way. It's a completely different thing. So, good. So what's wrong with that? Well, if we look at the data model, there is this X here. You see? So basically you have both fact tables connecting to both dimensions. Look at this. Do we have both fact tables connecting to product? To product?
Yes.
To product, yes.
Nice.
And to promotion? No. So you see how complicated it is for business users and for artificial intelligence. So this is a data model that has all the ingredients, but what is missing is that not all the connections are there. It's like if you go to Amazon and you want to buy something, you should just click on the things that you want to buy and buy it. You pay and you're done. But it's not like that. It's all about something behind the scenes that needs to be adjusted. We had that problem before, internet sales and product category. Even if I don't need anything from these two tables, I need them because that's the only way to connect internet sales with product category. So that was a problem that we solved by making this chain of tables. And now this, you need to add this connection like this. So you need to do this. And I'm good because I'm Italian, so I'm good with spaghetti. But it's not always the case. It's not so obvious. Promotion key, promotion is here. So now everything is connected the correct way. Guys, this is painful. It's painful because a data analyst sometimes even is missing this, but a business user is missing it 100%. And AI, something in between. You flip a coin. Sometimes it behaves as a data analyst, sometimes it behaves like a business user. So we need something more deterministic, more solid, more strong. We need something strong. Okay, so after 30 minutes, I'm ready to begin to present to you my thing. But as I told you, it's going to take less than 10 minutes. Look, so we have seen this. I go back to slide mode. Finally, we added the piece of a join that was missing, and now, no, I pressed twice. Where is, sorry, I missed, yeah. And so now you have this. You see, you have 700 and 300 only once. So it means that now, because I fixed the data model behind the scenes, now the numbers are adjusted. Not so reliable, huh? Honestly, I'm sneezing and the data is changing. What world is this? Okay, this is because of the join. Now, how is it with other BI tools? I'm still talking about the past. Well, because the tools are what they are still now. So what I will show you now, it will be still with Tableau, but with the Unified Star Schema. But now, talking about the other BI tools, in Qlik, you can do a lot of things, but you need to know the programming language of Qlik. Otherwise, you have the same problem as we had now. In Power BI, honestly, Power BI is the only tool that I know that is able to natively handle two facts joining with two conform dimensions at the same time. The X data model is handled by Power BI. Other tools would call it a loop, but in Power BI, that's not a loop. It's very important. It's amazing what Power BI does. ThoughtSpot, it's a disaster because you have to build something called a worksheet, which is an additional semantic layer that is tailor-made specific for the question. So you don't have a thing like you build your data model and then it answers everything. You build your data model and then for each business question, a technical user, technical developer must build the worksheet tailor-made for that question. So it's not self-service BI for users, and AI cannot rely upon a data model built on ThoughtSpot because it would always need the operator to adjust based on requirements. So finally, it's easier if the operator does the whole job. So we are not there with the data model. We are not there. And Looker is the most funny. I took a slide for you. You know what is this formula doing? Just watch it. It's so easy. It's obvious. It's calculating the age of a user. It's calculating, sorry, the average age of a user. I broke down the formula in all this cast floor coalesce, MD5 and everything. All this to calculate the where is that as average age. It's here. So it's calculating the average age, and it needs all this calculation. Do you know why? There's a reason. Because they first duplicate numbers. You remember we saw a few minutes ago 700 repeated twice. So they did to duplicate that. You would do, okay, sum distinct, and that's deduplicate. But if you do sum distinct, when you have a genuine duplicate, when you have 2 times 700 for a genuine reason, that also gets erased. So sum distinct doesn't work. So this is the way how they did the sum distinct, but to fix it. And finally, with this, the numbers work. But this is the way how Google does the average of age. Do you know how do I do the average of age? I write A, V, G, open bracket, age, close bracket. That's how I do it. And I can do it because I've built a foundation called Unified Star Schema, which in the first place is not creating any duplication. So because I don't have duplicates, I do not need to deduplicate. And in Google, they are still here. And trust me, they have very, very big problems on Google BigQuery of performance because this formula, guess what, is a bit resource consuming. And honestly, the last thing that we need in this environment that we have today, and we say that we care about environment, and then we calculate the average of an age of a person with this formula, honestly, this is not going to the good direction. Because then AI learns, okay, that's the way to calculate the average. So it's a loop. AI learns from us, but it also learns from our mistakes. So if you're a bad parent, your kids will be bad. So when you have kids, I suppose, you try to begin to behave good, no? So you stop doing all the bad things you were doing when you were young. I don't know.
You try to.
Yeah?
You tried to.
You try to. At least you hide it. That's the whole point. You're still smoking, but you go to another room. So, some thoughts. Okay, users are forced to do a data model. It's quite difficult to add tables. All the things that we saw. That's a summary of what we saw. A lot of problems that we have today. We need something easier and more reliable. So one day I woke up and I realized that Bill Linman, the father of data warehouse, was a person very active in the industry. He was writing, communicating, writing articles. So I wrote to him and I said, hello, Mr. Bill Linman, you are the father of data warehouse. I want to ask you a favor. I believe that data warehouse sucks. Can we please fix it? And he said, I agree, it sucks. Let's fix data warehouse. We are recording, right? Sorry, Bill. Yeah, I didn't say sucks. I was more diplomatic that time. So I spent a week with him. This is his house in Denver, Colorado. And we discussed about the problems that we have today on data warehouse. And it's actually not the problem of data warehouse, but it's literally the problem how we build a structure that can be easily consumed by the business users. Because data warehouse cares a lot about capturing. And all technologies are good in capturing because we have seen all this data ingestion very fast and it captures everything. Data Vault captures everything. But then the problem sometimes is how to read the data. You capture it for a reason because you want to read it. So data warehouse does the job. But I said to Bill, listen, we need to do something that, and one last effort, that from the capturing of the data warehouse, which is the core layer of the data warehouse, we need a presentation layer that simplifies things so that they can be consumed more easily by business users, by analysts as well, why not? So we save a bit of their time, and especially by AI now. So basically the concept that I wanted to share with him, I did it this way. I said, if these two cans are tables, this is a join. It's a can next to the other can. You're smiling. How is a union? If that is a join, try to think. So when I join two tables, basically I'm putting the columns of two tables next to each other. So like that, one can next to the other. When I do the union between two tables, is what sometimes you call the append. What do? You put the rows under the other rows, right? So what would you do with these two cans? On top of each other, exactly. This is a union. So this is, in a nutshell, the mindset that I wanted to change. Every time that we say that we are using data from that is in two tables, we say we join the two tables. So the idea of calculating together has now become a synonym of joining. But joining is not the only way to compute together the information that resides in two tables. Union is a cultural shift. It has always existed in the SQL language, but it's a bit inconvenient, a bit tedious to work with, so it's not very common. And also when you union two things, you want to line up two numbers, but one is here and the other is here. So they are not on the same row. So people say, if they're not on the same row, it's difficult to compute them together. But the trick is you union and then you aggregate. So you bring the numbers that were originally on different rows, you finally put them on the same virtual row because you have aggregated, moving away some detail that in this moment you don't need, you may need later. So when you remove detail and you just do by product or by time, by date, and so on, the numbers, they line up on the same row. That's the magic. You first union and then you aggregate. That's the cultural shift. So now I'll make a demo to you because I'm quite sure that you're a bit curious. We have I just have a, are we okay? Hey, the plane from Auckland arrived. Welcome. So actually I wanted to say that take the same plane that he was going to take. So basically the presentation would have started now. No, I'm joking, but not so much. I came yesterday evening because I wanted to be sure that I'm here today in Wellington. Okay, so what I do now, I take the second data source, I can open it for you, because I show you the heart of the Unified Star Schema. It's what I call the bridge, or the Puppini bridge, which takes the name from me. The Puppini bridge is a union of keys. So let me zoom in for a moment, so we don't need to watch everything, but rather be able to read. Look at internet sales and reseller sales. So both tables have 4 rows. Okay, and so when you do the Puppini bridge, you have as many rows as the sum of the rows of all the tables. So it's a very large table. But there are techniques to handle this. So these two tables, what do they have in common? Well, their own primary key, there's nothing in common. What is in common is the product. Both have the product. Then we put the product ID piled up. That's the key concept. You put the foreign key that points to the product ID piled up in the same column. You do the same with the promotion ID. You see it in the data model. I lost the data model. Wait, I want to show it to you again. So basically, these are two fact tables sharing two dimensions. So they both have the promotion key and the product key, right? So you see this reflected in the Puppini bridge. Promotion key, you have piled up the key, and also the product key, you piled it up. While these, they don't pile up because customer is only in the internet sales, but not in the reseller sales. And the reseller is only in the reseller sales, but not in the reseller. So you don't pile them up. You pile up things only when they point to the same table. As simple as that. And then, and so on. So, and then you have these sections that I call stages. You also have the one for product, because you may have products that do not appear in any fact, like product number 4. You see, it's not there. So we have a stage specific for product. Also because you may want to compare product with a category, so you don't need to use all the big fact tables. So every table that you have, you just take the keys, primary key and foreign key, and you pile up whatever points to the same target. And additionally, you also put in the Puppini bridge the measures, the columns that you will later want to aggregate by sum or by average. So that 700 that you saw earlier, it was probably some 400 plus 2, 1 and 2, something like that. All these numbers that we don't want to duplicate anymore, now we put them in the Puppini bridge. They will never be duplicated because it is built in a way that you don't duplicate numbers. That's why I don't need to build that ugly formula of Looker. Looker is deduplicating, but I don't duplicate, so I don't need to deduplicate. That's the thing, that's the trick. With this, now I'll make a demo. I know I'm a bit over time, but I guess we are still quite good. I'll make very quickly the demo. I open now Tableau Public, and this time I read the data when it is organized as a Unified Star Schema. So I don't read from the original file, but I read from the file transformed in the Unified Star Schema. There is only one rule to know. Whenever you start a report, you start with the bridge. That's the first table, always. You start with the Puppini bridge. So in this case, it's here. I double click, and it is there. Now, you remember all this 30, 35 minutes that I spoke about, all the problems that you can have with the classic approach? Let's start from the beginning. I want to make the report of internet sales by product category. You know what? I have an idea. I double click on internet sales and I don't touch the computer anymore. It's all automatic. Why? Because it's a naming convention. I make sure that only the key has identical spelling and all the other columns have different spelling. So Tableau, Power BI, they all do it. Okay, identical name. I do the job. So naming convention, make sure that you don't have duplicate names of columns like a zip code. Give it a context. Customer zip code, reseller zip code. This way, when only the keys have identical names, it's automatic. So I want the product category. I double click, I lift the hands, and it's automatically joined. Now, I don't need the thing I did before, so that I had to build a chain, the internet sales, and then product and subcategory. I don't need that anymore. Now, it's like when you do online shopping. When you do online shopping and you want to buy a pair of shoes. Have you ever seen system error? If you want to buy a pair of shoes, make sure that you also put on the cart a pajama. And then you don't need to pay for it, but it's for technical reasons. You don't want that, come on. So you just add to the cart what you need, that's all. So I want the reseller sales, guess what? I double click and I lift my hands and it is there. And you say, you know what? I also want the promotion and I want maybe also the reseller. I double click on anything that I believe can be useful and I add it. The promotion, I'll double click, I lift my hands and it's added. So Now that I have such a simple structure, imagine for a business user, for AI, it's trivial. AI should be very, very smart to make it wrong in a thing that you can, like, you must drive blindfolded and you still don't hit anything because it's safe, because the Puppini bridge avoids duplications, you have automatic joins the way they should be done. You should be really, really intelligent to break this. You should be a genius. It's easy by definition. So, as you can imagine, by doing this, you obtain all the correct numbers. I mean, I can pass you the material, and you can do, you can try it yourself at home with your favorite tool, because I showed with Tableau, it can be Power BI, can be ThoughtSpot, can be anything. So, these are 7 tables. As you can imagine, this ugly schema that we had, now, this one, it becomes like this. So it's a Puppini bridge in the middle, and all these tables all around. The size of the table is big, but there are techniques to make this happen in a way that you add to the cart not only the tables that you need, but also the portions of Puppini bridge that you need. And that's the thing I'm working on. That's technical. All this I did now until now is theory. It's like a new concept, a new idea. But the thing of putting together only the opportune Puppini pieces of Puppini bridge, this is a technical thing that depends on the technology that you're using for reasons that would be long to explain. But in DBT, for example, you have a macro that is doing the union automatically. So you have, it really depends case by case, and I'm working on that. I'm working on that now. So, but the bottom line is that whenever you have a data that is very, very complex, but not massively huge, you just build your Puppini bridge. It's big, but then everything is double-click. Imagine how much money you save from your employees, that instead of going there, oh yeah, I see that 700 is repeated, but the total is okay. Yeah, but you don't want to put that 700 twice, looks bad. Okay, I'll try to fix, and then a week, oh, I understood it's because one join was missing. All that nightmare is over. How much time of your employees you're saving? That's crazy. So this is the start. Let me work a couple of years more, and I will make it automatic. Also, the Puppini bridge dynamically dimensioned based on the request that you're doing. And then it's done. It's the connector, like in Avatar, they have the hair with the connector. It's your connector to everything. Every table has a connector that allows you to ride a horse or ride a bird. Every table goes with its own connector, and life is easy. So that's all for me for today.
Thank you.
Shall I? Okay, so what has been the reception to the Puppini bridge approach in the last 5 years? So by reception, do you mean like how it has been seen by the people, or I'm not sure. Reception.
I suppose you've published a book. Have you seen organisations making use of the Puppini bridge, and has it, what benefits has it given them?
Yeah. So my experience is that by reading the book itself, some people, even in New Zealand, a friend of mine here in New Zealand was able to build it. But I have to say that it's not because it's technically difficult, but it's just because it's a new thing, and somehow when you do it, you want to be supported by something. I noticed that whenever I was adding that little extra mile of attention, like having a call with them, it was much easier. So I had many people wrote me on LinkedIn saying, "Hi Francesco, sorry, you must be very busy. Everyone is telling me you must be very busy." I love that. I'm actually, I'm busy like everyone else. Can you help us because we are here? Oh, I had a call with the hospital of Canada a couple of weeks ago, and they told me, "Oh, Francesco, wait, thank you for your time on this call today. Is it okay if I call also the 2 other people, because they are our Puppini experts?" And I said, okay, Puppini experts, yeah, call the Puppini experts. So there are Puppini experts in companies now. I didn't know that. So they were a bit struggling because they had some doubts. I think that many things in the book should be explained with more detail. That's why I want to make now a course on Udemy that gives all this detail that is not covered in the book. I believe that the explosion of the usage of this solution is yet to come. I saw a lot of curiosity, like you seem to be intrigued today, but from there to moving to action, I noticed that it requires something more. And that's why I'm also being helped by the friends who are hosting us today, like OSS, who had the idea to make these presentations, and you guys hosting me in this building of the innovation, of the business innovation. All this is helping to democratize this solution. Technically, it's not challenging, but yeah, it requires that spark also for people internally to a company to say, hey, there is a solution. Okay, where is that? Where is the website? I don't have a website. I find it an old thing. So it's difficult for them to sell it to their boss. Shall we do it? Unified Star Schema. So it has to reach the momentum where people say, oh yes, they built it also in my previous company and it works. And then it will have the sufficient critical mass to become, in my opinion, the standard. Whenever a company has Kimball, they can turn it into this without losing the Kimball implementation that they have made. So do you have a rough estimate between big data but not huge? Yeah, that's a very nice question. Is it 100 lines versus 1,000 lines per day? As long as not millions lines per day. I have a very, very simple question to your answer. No, the other way around. Answer to your question. To me, data is not too huge when it is able to fit in memory. So as I said at the beginning, I'm coming from Click. So forget about the Unified Star Schema for a moment. So think about you have just one fact table and 5 dimensions and you use Power BI. So do you use the import mode or the direct query mode? So if you are able to use the import mode, it means that the way how your system has been dimensioned, if you're able to do it and pull the entire table and all the entire dimensions inside the Power BI, that is what I call not too huge. In the moment when you have a lot of rows and the import mode is getting stuck downloading for 2 hours, that's too huge. That's the threshold, import versus direct query. Or in Tableau, it's live versus extract. So whenever data fits in memory, it's not too huge.
Keep thinking of your questions. I have one idea, which is maybe we should get people to say what tools they tend to use. You know,
Yeah.
And then maybe it'd be useful for you to comment on what approach they might think to take for implementing the Puppini bridge, because it sounds like you're starting to talk about the technical implementation and this tool and that tool. So I'll make a poll now, and we can see what people are using.
There's a method, tool agnostic, right?
Yeah.
There's a method.
Yeah, it's totally tool agnostic. And the good thing is that every business intelligence tool on Earth is based on the Kimball approach. And the Kimball approach is based on the star schema. So this is a star schema. So it's by definition compatible with all the existing BI tools. So in Looker, when you create a model in Looker, and especially when on top of a model you build an Explore in Looker, that Explore, you need to start with the main table. So the mindset of Looker is that there is a main table and then the other dimensions that join to the main table. And that's how Tableau was until a year ago. So until April 2024 in Tableau, you could only have one fact table. So the BI tools are built in a way that there is the main table and then the other tables. And that's exactly what the Unified Star Schema does.
Earlier you mentioned, there's more than one universe.
Yeah.
Well, so how that comes about, through legitimate or historic reasons, this organisation here was formed out of about 10 others.
Yeah.
What else was going to happen? So it's nearly a necessity if that happens when you've got a merger.
Yeah, yeah. So that's actually the problem that was in theory solved by the data warehouse. So whenever you have to deal with the mergers and acquisitions, data warehouse, the enterprise data warehouse, is supposed to be the answer to your problems. Except that working with Teradata, I was working, for example, in Nordea, a large bank in Sweden, and they acquired a few more banks. Each bank had their own system, but the timeline for the creation of data warehouse was 5 years, and it ended up being more than that. So data warehouse is probably the solution, but there's a lot of time to build a data warehouse. Wow, Power BI everywhere.
I do think there's one thing which I do like about this approach, and I find just the whole topic interesting, because normally people have to deal with data problems by themselves. The way you're modeling your data tends to be something which is your universe, and other people haven't got the same problems as you. But this is something which addresses a specific problem and just overlays whatever star schema you've already got. So you don't have to dismantle anything, you don't have to replace anything. It's just if you've got a problem, you can lay this over the top, and then those problems disappear. And it's low effort as well. So from that perspective, I looked at it and I went, this is cool. It can make some people's lives easier if you've got this specific problem. If you haven't, it doesn't matter. But it's difficult sometimes to understand what options there are and to test them with other people as well.
Yeah, it's not disruptive. So when an organization already has a system in place, they have already chosen a BI tool, a data warehouse, and they already have a presentation layer built on the Kimball dimensional modeling, well, that's the perfect scenario to keep everything that you have and add the layer on top. So you don't need to reinvent, rebuild everything. Everything that you have is fine. Instead, if you have nothing at all and you have your data that has not been transformed to Kimball, to me it's even better, because the Kimball very often is killing some of the keys that I need. Because Kimball doesn't consider the fact that a fact table can have the key of another fact table. That is a bit forbidden in Kimball. So if you have not built your data in Kimball, you can build it in a way that is more powerful than Kimball. But if you already have it, it still works. The name convention of joint tables in a data warehouse usually contains the contributing tables. The bridge acts like a mesh that may lose the naming essence. Absolutely agree. Let's remember, call it the way you want. A data warehouse typically has 3 layers. So they used to be called staging, core, and presentation. Now with Databricks, it's called bronze, silver, gold. Call it blue, green, yellow. The point is, the core layer of a data warehouse must have this, and I agree. So the core layer should tell you where data comes from. Lineage is very important. But when it comes to presentation layer, the business user is not thinking in terms of systems and lineage. The business user is thinking in terms of what they need. So it's more important to give names that are understandable by the business users. If the business users have knowledge about the system where it comes from, you can still put it in the names. So I don't give any rule to the names. The only rule I give is don't call 2 different things with the same name. That's all I'm saying. So if you have twice the same field from the same source and you give it 2 different names, it's already weird. But if you have and you give it the same name, I'm asking, okay, then why do you have it twice? So don't give the same name, that's all. And again, that comes from Qlik, because in Qlik everything is put together. So business users, they see a list of things, of column names that should be self-explanatory. They should not depend, again, I said zip code. Zip code is self-explanatory when you put it in a context where it's in a column called, in a table called suppliers. So it means that it's the zip code of the supplier. But if I take all the column names, I write them on a piece of paper, I put them in a hat, and I pick one column name, I need to be able to read that column name and know what it is. Not like that I need to know what table it comes from. Each column name must be self-explanatory and hence unique. That's my golden rule.
Thanks for the short introduction. I'm Konrad. I'm based in Auckland, so not too far away from you here in Wellington. And I'm still, we are remote first. We are living around, like we are working and living around the world. And we have, like, as a company, a very strong consultancy BI background. So a lot of people who are founder or key stakeholders worked for many years in consultancy and hated a lot of things and said, like, oh, we want to do something differently. And but before we go into the product, I just want to give you a quite short introduction about the product, and we'll also share my screen so that you can nicely see it. Share the whole screen. And going here. Okay. Yeah. Okay. Cool. Yeah. So like just going like around, so like we also like belonging to the whole area of visualization somewhere between Power BI, Click, Tableau, however, like Sigma, however all the tools are named. There are a lot of them. And but before we are going, I want to like go a little bit like where to the strategic approach there I currently see in the whole BI world. Like the starting of data, what I was seeing was mostly like still with reporting, and then even people, they analyze reports very long time ago, even like they just put something and they just even went through paper reports and marked line and then calculated things together. But still, this was also doing analytics. Then we have the whole system of the BI area, and now we already had it in the BI area, but we have it now, I think now much more with cloud things, that we are having more data products. So reporting is just very one directional. You even just have a paper and the paper is fixed. You have then the BI, and the BI is you're getting, first it was even in the cube world. I think maybe some people read it still even remember the times in SQL analysis reporting. So there you need to build your cube, but it was very like limited what you want to analyze. Then you had more the kind of free flow BI area there everybody can do everything, also the idea of self-service, and now you have much more that interaction also with data. So people writing things to the data back, or they also do things that they have a Python model that is running on top or something else. So you have ML models. So it's just much more interactive than just consuming data. It's really interacting with data. So this is one big thing that we currently see as a trend in the market. So the first thing is, yes, data is moving to the cloud with a lot of advantage out of that one. But the most of the tools that are in the market are not built for the cloud. And it's not against the tool itself, but then the tool was designed and people thought about how to build a tool or how to like use it. The cloud was not there. And now here it's mostly Snowflake, but I also want to mention like Databricks, Google BigQuery, and ClickHouse, and all the other tools that are currently just upcoming or already there in the market. They just change the things. And they also change a little bit like to the topics of sizes. Then like for me, table were big with 10 million, 50 million rows in a Snowflake or Databricks. Even data with 2 billion rows are quite good handleable. So I think also like the topic of Francesco, how big can be the model? The cloud infrastructure really changed what you can easily load, and also can have as a bridge table quite easily. Yes, it also sometimes comes at compute costs, but there are also compute costs if you join a lot of tables, or you just have a long bridge table that you just join one element into from the Snowflake. That original BI tools, they really needed to fulfill everything. So they did the ingestion, they did the storage, they did the transformation, and they also did everything. What we currently see is, you can name it kill, but we mostly say like that unbalanced BI. On the right side, there are just some examples, but there are constantly more products that are coming in. I just had like some things, but for example, data transformation, DBT is very successful. On storage, you have very successful, I think, the free of them we see. And there are also like other tools that at the moment also absolutely concentrate on the visualization, or I would even say like interacting with the kind of data layer. So it's more the data approach. What we have as a very, very strong principle, we could even say like that we are a little bit religious about, is we say like we never copy data. So we have that that we play the data where it sits, or where it lives, and this has a lot of advantages that we will later see like as a nice outcome out of that architecture shift change. And it is also something that we think is very important. If you don't copy data, you have also the advantage that you can interact with the data. Because if you only interact with a copy, the original has an issue. Or you interact with the original one, but then the copy is not the same. So it has automatically out of that change a lot of advantages. I just want to give you like here the kind of short interaction. And yes, if people Power BI or Tableau or Click or other products will say like they raise their hand and say, yeah, but there's also a direct query mode in Power BI or Tableau, whatever. Yes, there are modes. But what you usually see is you have that amount of features that you can use in your product, and as soon as you switch to direct query mode, there is only a really subset. For especially in Power BI, you see it massively because you cannot use DAX or you cannot use other things. Yes, it is a cool tool, but as soon as you go into direct query mode, it is very limited. And I just also want to name here, for example, Sigma Computing as one of the other big vendors that I currently see on the market beside Strato. They just have visually just a completely different approach how they handle data. The data in transit has the big advantage. What we see first is, what I can mention is we don't store data, so we don't have security issues. So like you have your data under control, you take care that you manage it, and your other vendor is just like having that in transit. So as soon as the user gets the data, it is removed. The second important thing is, if you store it on your side, is you only do the security model once. Currently, you do the security model twice. Because what you need to do is you need to do it in Power BI or in Tableau or in whatever, and you have it in your Snowflake. And then you get it really on one place together. And the other nice thing is you want to have even always the security model really with your data together. Because if things get wrong, it's much less probability if it is in there. There's another real advantage that is just like automatically. It's a feature that comes out of the box without any interaction. Is if you also authenticate each user, your end user, directly into your database, so that you don't use service accounts, you automatically get traceability and auditability out of the box because you go into your Snowflake query history and you see, okay, Konrad fetched this one. Francesco fetch this one. So if somebody comes to you and says like, oh yeah, we have an issue that customer left, or we think that here is maybe someone is stealing there, whatever, you just go in your database and check what was the person reading at the time, how much, make statistics about it, and use it and stuff like that. There is another big advantage is you only have compute costs only one. What I mean there is, yes, like the tools. The most tool, Click is, I think, already started it. I think Power BI also have it partly with the embedding approaches, but still you're somehow paying compute twice. Because if you copy the data, they also have cloud costs or you have local infrastructure costs. So you need to pay twice. Because you also have it in your cloud data warehouse, there you extract the data, and then you want to have the data up to date. So you maybe not only extract it once a week, you maybe abstract it once a day, but then people say like, yeah, once a day is not enough. Okay, that's once an hour. Then you get maybe once every 5 minutes. And then you have like a lot of load on your cloud data warehouses, and then you still have a lot of code that you somehow pay. And the big advantage is you pay it only once because of that. Last but not least, but this is something that we build in our product, we have used a lot of the ideas of the Unified Star Schema in our product. So we somehow do it magically that you can still have your model like you wanted to have it, just simple with your table. But in the end, we take care that the kind of totals are correct and all the things because we somehow view this interim layer in the SQL query and then patch on top. And this makes the SQL extreme, fast, simple, and still correct, because this is the important thing what you in the end want. As an end user, you want to have correct results. Just like to give you like a little bit short introduction where we are coming from, where we are doing things differently. And here we'll just go over. One thing is what we also like very about is like we are fully no-code approach, so we do everything in the visual way with advantages, disadvantages, but we see that usually adoption in organizations is much faster because people don't need to learn complex languages like you have in other things. So this is what I just showed us. On the left side, you, for example, see how we build meshes. It also sometimes people don't like it because it's like, I need to click so much. But the nice thing is now, as I can also show it later, is you have now that nice AI query. So you just put in what you want, and then it gives you like a suggestion. It is maybe not 100% correct. In most cases, it's 100% correct. But otherwise, you can just visually fix it what you want to have differently. On the right side, and I will also then show you in the product, it looks like a little bit like PowerPoint. You, here at the moment, nearly the things are not overlaying, but you can extremely easy drag and drop things. If you want to have something with round corners, you just put a rectangle with round corners around. So you visually build like in PowerPoint, and this makes it very seamless for the people who know to use PowerPoint, and the most people know to use it. On downside, you see something that is looking a little bit more complex, but this is inspired by Scratch. If you have maybe kids that are learning to program visually with 3 years, 5 years old kids learning already with that one, especially in schools, they heavily use it. And this is a visual language that was introduced by some researchers, and we have implemented the same mechanism in our product. So you can visually program and can even write complex write-back applications, workflows, whatever, but still without coding, and it makes it quite easy for people to learn. Just like to give you like a very short update. And this is something, so currently our customer base, also just short talk about this, we are heavily US-based because the customers usually already have all their data in the cloud. This is something where we are struggling. You also hear from my accent, so I have German background maybe, so also maybe you heard from my accent. So in Europe, the people are going into Snowflake, going into Databricks, but they are still very often not there. What you, for example, mostly have seen on the right lower corner, this is a healthcare provider in Georgia. They are providing it to, I think, roughly 800 hospitals, analytic services to them, and they had a massive cost saving against Click, and this just like there because, and the another advantage there is because of our no compute costs on our side, we even can allow unlimited use cases, so that you can even say like, okay, I just buy a license for some use case and then I can roll it out. And if a hospital just have a new nurse that is joining or another doctor that is joining, they don't need to reach out and need to buy a license forever. They can just go and do whatever they want. Just like to give a short wrap up before I will give you now the next minutes, and I try to also keep it short, a little bit of an overview. What you will see is you can build, and this is also something that you will, yeah, I shared. You can build complete different looking things, like you can also put things, but the variation is, just go somewhere. You can do also all the things that people are usually used to do, so that I can say like, okay, I can filter something, so I can have full interaction, like what I would say, like what I'm expecting is a like minimum layer. What is something that is heavily used and that people absolutely like is that they use the kind of custom report. I name it usually, I say like Excel reporting tool, because what we heavily see is that a lot of customers using, like a lot of end users just use it as a tool to provide something, get a table, and then they just do export to Excel. It is not perfect, but I still say like this is the this is where we're living in. But it for a lot of customers, it reduces a lot of ask for just new reports, because what in the end people do is they just get a new report, and out of the report they just export it again. So you as a department just get it away, because you say like you have your custom report. There also now the AI is very good working, so that the people can say like, okay, I just want to have a revenue per let's like per year, or other things like you would more know from a forward spot. And there's a big difference if you go into the approach that you directly go against an SQL. What you can do here as a designer is you can even define your different data sets, so you can limit the guardrails, so you're taking care that people can only select the things that really make sense, that are working. And if then users use that kind of capabilities, it's working quite good. So it's like the AI itself is not the problem, but what you see like permanently in LinkedIn, that people complain, yeah, I just was doing this one and it just like returned something that's totally wrong. Yeah, but you need to scope it. You need to give the AI a lot of information left and right. And this is something that we heavily see here as possibilities to do that. So we're also working on this one, so you can use it for insights, so that you can, for example, summarize dashboards and all that kind of capabilities. Here, I just want to show you as an example, a quite simple write-back use case. So you wouldn't maybe not do this one with a BI tool, but we even have no customers that are doing use cases that have nothing anymore with BI in common, because they don't analyze data, they just put in data, but because it's so easy and that you can use it. But I would just like use here an employee, I would just give a feedback source and say like, okay, it was in person, I give him 5 stars. I give him a comment and say like, LinkedIn, so it doesn't make sense now for this one, but just to put something in. And the difference, what you see is you instantly see then here that this was a feedback from received. You see that I gave here this one. What we also do here as an example is that we even calculate the sentiment in our Snowflake on top of it. But more important is, the nice thing is now is we also build things on the cloud, and we also take care that we really use Snowflake capabilities. So we just, for example, now go roughly 20 minutes back, because I can now use Snowflake time travel capabilities. And now I'm just don't see that feedback anymore because it was gone. Now I go to the current time and I'm back. So we really build things that we use and give any kind of features that this now cloud data warehouses give to the end user. We really deliver the features also always in part of our platform. Just like as a very simple example, I would now just go through. I think I didn't want it like to. There's another example there. This is done, for example, as a budgeting system, so that people can here add things. You can even have a simple improvement workflow. At the moment, this improvement workflow would not really make sense because, quite simple, because I can self-approve it, but here in the demo it's much more easy if I can also self-approve it. So I just changed the 50K software hosting cost, and as soon as I now put here the approve, you will also see that all the KPIs will instantly start to change, because now it's an approved statement and I can see it. Beside this one is I could also see instantly always my track history of all the changes that were done in the past, so that I can now know a few. Beside that one, we're supporting still generating reports and even nice Excel-based reports. Why we do that? Because we believe as we do the things that the customers really need or that they ask for, and not what we religiously think about. There were a lot of BI vendors that were like saying like reporting instead, everything need to go into this one, and then people still constantly build this one. We absolutely believe in only that we say like don't copy data. So there we a little bit have a clear opinion, but for the rest we say like whatever you want, you do it. So we have also you could also generate it as PDF. I would just now open an example.
Just sorry, we'll have to get out of the room before by 1:30. So maybe
okay, so we have
2 minutes.
So 2 more minutes.
Okay.
No problem. Okay, so no problem. Yeah, just like as one of the last examples. Before I will now just go short into. I will just want to show you as the very last seconds how you could, for example, edit something. And to have that kind of understanding how this is done, just going in here as an example, that everything is also like a product that you would like know from like Sigma or whatever, not Figma or so like you can just like put in your visual elements, you can move them around, and this is what I like meaning with like the PowerPoint. It is extremely convenient for people to get into, to play with that one, to build things. And the rest is fully in the idea that the people don't code, they always like put the things together and then use it. Below, as a last question, if people ask, yes, we have a semantic layer between. So in the product, there's a semantic layer that combines the things. We don't copy it. We just have that semantic view. It defines how the things are connected, and then we automatically build everything on top of it. Because we are also so short on time, also like if anybody afterwards have questions, I would more than happy just connect to me and let's have a chat on a coffee, whatever. nice to give you a little bit more deeper introductions. Thanks.
Well, great. Well, thanks.
And again, thanks for being
Very
there.
important.